the project really is trying to, bring the political considerations back into discussions about financial regulation and regulatory policy toward the financial sector. And one of the main important policy debates has to do with how you regulate very complex markets like financial markets. And so we wrote about it, but in writing about this question, it occurred to me that there's not as much work on the political economy of regulating in light of complexity as there might be. Now, clearly, there's a lot of work on the informational problems in regulation, but I want to argue in part in this paper that doesn't really help us to get at some of the kind of key questions that come up in the discussions of financial regulation and how to structure the new regulatory regimes to help deal with increasingly complex financial markets. So let me, to kind of give you a sense of the kind of flavor of the type of argument I'm going to make in the paper, the structure of the model, let me just start with an example, again, drawn from financial regulation. And this has to do with the regulating of the so-called flash crashes. So as some of you may remember, back in May of 2010, the Dow Jones lost about 900 points in minutes. It came to be believed that this crash was this temporary crash had actually recovered fairly quickly. The belief was that this flash crash was exacerbated by high-frequency trading, and that the optimal or reasonable policy response was to institute circuit breakers, which would stop trading in securities whose prices changed too rapidly over too short a period of time. Okay. So how did the regulatory process go about doing this? Well, the first mover in the regulatory process was the Financial Industry Regulatory Authority, known as FINRA, which moved first to formulate the new rules for circuit breakers. Okay. So it wasn't. So the first insight here is that the first regulatory response was not by a public regulator, but it was by a private regulator. The industry association that regulates exchanges. So following the first move by the private regulator, or the self-regulation of the industry, then the Securities and Exchange Commission moves. But given that the private regulator has already moved, then that leaves the Securities and Exchange Commission with the following choices. First, it could accept the FINRA standards, could leave them in place. It could modify them in various ways, or it could develop new standards, new rules from scratch. Okay. So this highlights the possible trade-offs that a public regulator has. First, it could accept the FINRA standards, but it's going to lead to a regulatory outcome that's going to be more targeted toward industry. It's going to perhaps have circuit breakers that are too loose, that are going to allow too much volatility in the markets, and not take into account the positions of the public or small private investors. The second choice is that it could modify the proposal to lead to outcomes that are closer in expectation to what the Securities and Exchange Commission wants. But one of the issues about public regulators, again, to bring in where I'm going to go with the ideas about capacity and complexity, is the SEC, which is mostly composed of lawyers, not financial economists, would probably not have the same level of expertise or access to the same types of data that FINRA has as the public regulator. And therefore, they might be able to move policy closer to the public interest or that of its legislative principles, but it might lead to more uncertainty about actual outcomes and have unintended consequences. Or third, the SEC could just design a new proposal, which would, again, potentially have even more unintended consequences than simply trying to do slight modifications of the original FINRA proposal. So my model is really to kind of this example I came up with after the model, but the model that I developed here really kind of captures, is intended to capture these trade-offs. So the key concepts here are kind of the complexity, and here it's going to be a very kind of reduced form of complexity, but again it's going to be the idea that it's not simply an informational problem that the regulator can somehow extract, or revelation principle type problem, but we're going to have, in a reduced form way, we're going to make the informational problem a little bit more difficult. The second insight is that I'm going to develop is that public regulation often builds on private regulation or self-regulation of firms. This happens, it's the easiest to see in the example I just gave you, where again you have a kind of a trade association or a regulator of the firms. Clearly they're doing regulation, the private regulator can build upon that or supplant that. But it's also true if we're thinking regulators acting directly on firms. Because one thing you can think about a firm is the regulator of its subunits, and it has regulators. This is particularly true of the financial sector, where essentially a firm is basically the regulator of its trading desks. So we can think of firms as having risk controls, and then public regulators can build upon firm-level interest controls. And finally, the model, I may or may not get to it, has some kind of observations about the role of interest group influence or capture. So the motivation here, so again, there's lots of work on the political economy regulation, so let me kind of motivate why one more model. So typically in the political science work, bureaucratic expertise is exogenous, or it's going to be generated by some kind of human capital investment. This is quite different than regulatory economics, where the regulator's extraction of information is kind of the central problem. So one of the things that I want to do here is to kind of more endogenize the expertise. Second, political science work often takes the kind of capture of bureaucrats, or the extent to which the bureaucrats' preferences diverge from that of the legislative principle or the public is exogenous. Here I want to endogenize that. I want to think about optimal regulatory structures. How much capture really does the legislative principle want there to be for reasons having to do with capacity and complexity? Third assumption, typical political science work, is that bureaucrats are good at implementation. Want to relax that. But I think most importantly, there's little distinction drawn between information and knowledge. And dropping the models in political science are often cheap talk games, where the central problem of the regulator is to get a piece of information from the regulated firm and then make policy based on that information or posterior beliefs about that information. Okay. So here, when I talk about complexity, again, very simple, reduced form. All I really mean is that bureaucrats are going to find it very difficult to establish autonomous sources of information about consequences, and that they're going to be highly dependent on the regulated firm or the interest group. And this happens for lots of reasons in lots of different industries, especially true in the financial sector, which is kind of a motivating example, where a government can't afford talent, or there might be educational or social ties between the regulated firms and the regulators because of in and outer revolving door things. And it also comes with cognitive capture, that regulators and the regulated firms often will have similar beliefs about the efficacy of particular markets, arrangements, and so forth. So let me move to the model. It's going to be a very simple model to kind of get at some of these issues and try to enlighten these trade-offs. Three actors: a legislative principle, a regulatory agency, and a firm, with a one-dimensional outcome space X. Okay, so it's not going to be a policy space. Policy is going to be, for reasons that will become clear in a second, policy is not going to be particularly well-defined in this model, so we're going to talk about outcomes. And then again, we're going to have very simple preferences, quadratic preferences, with different actors having different ideal outcomes. And just to make everything look simple, I'm going to let the legislative principle have a preferred outcome of 0, and the firm have a preferred outcome of 1. Okay. So here's the kind of the information structure, the way I'm kind of thinking about the reduced form for complexity. So here, I'm going to model it in that the inferences that agents, say uninformed or less expert agents, draw from observing the policy choices of more expert, higher capacity agents is going to be limited and local. So this main assumption is that a non-expert cannot observe an expert's attempt to implement a particular policy X and then use that information to precisely or to do a good job of implementing some other policy X prime. So in the kind of language of this literature, I'm going to say that the information is going to be not completely invertible, it's only going to be partially invertible. So if I'm the SEC, I can look at FINRA's attempted implemented policy outcome, and I can change it, but I can't implement my own preferred outcome perfectly based on the observation. I can't invert out the information or the expertise of the firm. So to model this, I'm just going to have that the non-expert is going to try to, if it tries to implement some other policy X prime after observing an attempted, a targeted policy X of the expert, then the realized outcome is going to be a new outcome with a mean of X prime, the target of the non-expert, plus some error omega. And then I'm going to allow the variance of this error term to have a particular functional form, which is going to be, is going to have the following. So this variance is going to be this function theta, which is going to be a measure of the kind of baseline measure of complexity. So higher theta, the higher this variance, and that's a baseline. Then we're going to have some C of D, which is going to be a function of the distance between the expert's target policy or target outcome and the non-expert's target outcome. So the greater that distance, the more uncertainty, the more this variance is going to blow up. And then, for reasons that should become clear in a second, I'm going to allow this function of the distance to take a particular functional form, and I'll explain that in a second. And then it's going to be divided by 1 plus E, where E, as I'll describe in a second, is a choice variable of the expert, or in this case the firm, which can reduce the underlying uncertainty associated with the policy, but at some cost in terms of having that investment expropriated by the regulator. So again, the status is going to be a baseline measure of uncertainty. So when I say complexity, I really often mean theta. Then C of D is going to be the extent to which this uncertainty is going to be enhanced by modifying the firm's policy choice. So if you don't, C of 0 is 1. If you don't modify it at all, you're just going to get the uncertainty is going to be the baseline uncertainty. The function, this uncertainty cost function, is going to be increasing in the distance between the target policies, and it's going to be convex, increasing. Now I have this parameter kappa, which is going to be kind of a measure. It's going to control the extent to which the uncertainty blows up given a unit of policy change. And it's going to have two interpretations. One is, you can think of it itself as another measure of complexity. It's like if I change the policy a little bit, what's the marginal increase in the level of uncertainty? Or you can also think of it as kind of regulator capacity. How good are the regulators at modifying the policies? Then one of the kind of important pieces of the model is that the firm is going to basically this is the idea of self-regulation, the firm is going to be trying to reduce uncertainty in part of its target policies, in part by investing efforts in informational investments, expertise investments, Okay, so they're going to choose some level E at a cost of gamma F of E. So we can think of this as, at the firm level, we can think of this as how much they invest in risk controls and internal controls, how much the firm is investing in its own regulation. But the trade-off for the firm is going to be that if you increase these investments in transparency and risk controls within the firm, it's going to reduce the marginal costs of regulatory revisions by the public regulator, so that these investments are going to be partially expropriable in a way that I will demonstrate in a second. So again, just a couple of examples. We might have a private regulator who requires reporting requirements from covered firms, so like FINRA. The public regulators might build upon such a system or demand that the reports be made to themselves. A firm may conduct internal studies associated with the risk of different trading strategies. These reports may be subpoenaed by regulators. So the idea is that firms can be involved in their own levels of regulation, but that they do so at the potential cost of those regulatory efforts being used by private regulators to move policy further away from the firm's preferences. So let me, so given this setup, let me move to the model. So the first stage in the model is going to be a choice by the legislative principal, and they're going to have three choices. They can essentially decide not to give a public regulator any authority, so as to let the firm do its own preferred policy making. Principal can ban particular activity of the firm, or it can choose to regulate. So one of the things that try to get at the model is the extent to which perhaps the complexity problems are significantly large, that you just choose laissez-faire. So you hear this argument a lot in financial debates, and that the complexity of regulating derivatives is so great that we might as well not regulate them at all. Others might say, well, the complexity of regulating derivatives is so large that we shouldn't have derivatives. That would be the second choice. And then the third choice would be, well, we will go ahead and try to regulate them in some but imperfect way. So just quickly, the regulated case is very simple. The firm chooses its preferred target policy of 1, and you can, so then the firm then chooses that policy 1, then chooses its investments in internal controls to reduce the variance of that policy to the optimal amount. You can compute the unregulated level of firm investment, and then compute the principal's utility. The way you can think about a ban is that a ban can be represented by some default policy. So, what would kind of the target policy be in the absence of a market? And then in some default variance. So these are just parameters, so you can do some comparative statics on these parameters in terms of when you would choose a ban, when you would choose unregulated. And you might also think that this might be a way of capturing bright line rules or very simple rules that could be implemented with some inefficiency, but not a lot of flexibility. So I'm going to talk mostly about the regulatory case. And here, the structure is going to be that the firm is going to choose some target policy, XF. It may or may not be its ideal policy. And it's also going to choose an investment level E, essentially how well to implement this policy within the firm. And then after the firm chooses that, then the agency is going to choose a modified policy. XA. So obviously, then the agent will choose its modified policy. We'll choose XA, its modified policy, to minimize, again, because we have quadratic, to minimize the distance between the expected outcome, which is just XA, and its ideal point, minus the variance associated with adjusting the policy from XF to XA, and then that produces a best response to the original choice of XF and E. One of the things to note, because of the simplicity of the model, the policy, the target policy of the agency is always going to be a weighted average between its ideal point and XF minus kappa, which is related to the original choice of the firm, where the weights are given by the amount of investment that the firm has made, E, and the level of complexity. So as the level of firm investment in implementing this policy goes up, it makes it safer for the agency to do more regulation, so it moves the policy toward the agency's ideal point, but that's going to be tempered by the baseline level of uncertainty. So we're always going to have these kind of the policy choices being weighted averages, where the weighting averages are the underlying level of complexity and the firm's level of investment and implementation. So there are going to be these two cases: this acceptance case and this revision case. And again, in the revision case, the final target policy is this weighted average of the agency's ideal point and this function of the firm's initial offer. Just some observations about the revision case, where the agency is observed to regulate. The firm's policy choice is going to depend only on its ideal point and kappa. It's not going to depend on E or theta. I won't go through this, but two effects cancel each other out. As I've said, then the final policy target is going to be a weighted average. Once that we take into account the optimal offer from the firm, then the final policy target is going to be a weighted average of the agency's ideal point and the firm's ideal point, with weights of 1 plus E and theta. So we can see that there are two sources of rent to the firm. There's an agency rent increasing in A, so as the agency is more, shares preferences more with the firm, is a more pro-firm agency, that's better for the firm. And then there's going to be this complexity rent that's increasing in theta, so the firm does better off when the policy area is more complex. But because we're taking this weighted average, both of these rents will be decreasing in the level of effort that the firm makes in implementing its policy within the firm. Okay, so this is the expropriation problem. So we back up to the final stage. The first stage. Now the firm is choosing its investment. So the optimal level of investment by the firm, or information gathering within the firm, is going to be weekly increasing in the agency's ideal point. So the firm is going to be less worried about the expropriation when the agency is more pro-firm. Okay, so we don't worry so much about kind of being obscurant within the firm if we know that we have a sympathetic regulator. It's going to be increasing in the baseline uncertainty, so the more uncertain the policy is, the more the firm's going to try to reduce it. That's pretty straightforward. It's going to be weekly decreasing in kappa. I haven't talked much about kappa, so let me skip over that. And then, of course, not surprisingly, it's going to be decreasing in the marginal cost of effort. So the punchline here is that the firm is going to choose to internally regulate less often when they have a hostile regulator than when they have a partial regulator. And so this is going to feed into the principal's choice. Now we're going to endogenize the ideal point of the agency, so this tension is going to feed into the principal's choice of agency preferences. So now we have a trade-off. If the legislature or the principal chooses a more hostile agency, they'll get a target policy that's closer to the principal's ideal point, but there'll be more uncertainty because the regulatory adjustment that the agency will have to make will be greater, and the level of the firm's investment in implementing its own internal controls is going to be reduced. On the other hand, if the principal appoints a more pro-firm agency, a less hostile agency, then the amount of regulating in equilibrium that the regulator is going to have to do is going to be less, and that reduces uncertainty. And then the level of investment in implementation made by the firm is going to also go up. Okay, so there's going to be a expected policy variance trade-off, and so then the principal's optimal agency ideal point will then be, after another condition is met, basically having to do with the slope of the uncertainty function when the agency has an ideal point of 0, then the principal is going to choose an optimal agency ideal point that's strictly greater than the ideal point of the principal, which was 0, and it's going to be less than a bar, which I skipped over, which is the level of the agency ideal point in which deregulation is the preferred outcome. Okay. So we're going to get a prediction that under certain conditions the principal is going to delegate to a pro-firm agency. This is consistent with some models that Galmar and Patty used in their recent book. And the idea here is that the pro-firm agency is able to get more information, and therefore that's a good thing. But it's contra the type of work in political science similar to Epstein and O'Halloran, where a principal would want to delegate to a more anti-firm agency to provide contravailing signals to the principal. So, just point out, this the model I developed. Obviously, it's very similar to the kind of some cheap talk models that are used in this literature. The main difference I'll point to is that in pure cheap talk games, uncertainty has no effect on the expected policy outcomes. So they're signaling. They're signaling. The receiver receives a signal. It reduces the variance of their priors. They get posteriors, but then they choose policy based on the expected their expected ideal point given the posteriors. So in a signaling model, cheap talk model, the signaling reduces the variance of the policy outcome, but not its expectations. So in the pure cheap talk model, you would not want to have this strategic delegation to a pro-firm agency because it wouldn't change. It would only change the variance of the policy outcome, but not the expected policy. In a cheap talk model, uncertainty reduction is greatest when the sender and receiver share similar preferences. So my model has most of these predictions. Predicts that there's less variance when the firm and agency have similar preferences, but it has this kind of expected policy effect from this delegation of pro-firm agency. Some extensions the model. So the first extension I talk about in the paper has to do with capture. So I extend the model to deal with a situation where the firm might also try to manipulate the agency decision-making through direct transfers. What I find there, not surprisingly, is that the firms do better when they can make direct transfers to the agency. But the comparative statics with respect to complexity and the other, in terms of the other parameters, are pretty much the same. So So capture is one extension. A second extension I do is I look at cases where the agency itself can make investments in the reduction of uncertainty, similar to those of the firm. And there it's going to be a pure free riding case. So it's going to be the institution with a lower marginal cost is going to make all the investments and uncertainty. So if the agency has a higher marginal cost of effort than the firm, then we get the original results. In the case in which the firm has a higher marginal cost of effort than the agency, then the agency will make all of the investments. And then that upends the prediction of the pro-firm agency. So in a case where the agency has lower marginal costs for the investments, then it's going to upend the prediction, and the principal will want to have an agency who's even more anti-firm than the principal is herself. And I can talk about a few others, but those are the main ones. Well, I'll talk a little bit about how, going forward, I plan on testing the model and doing some work with a graduate student. So one of the problems with kind of testing models like this is that it's very hard to do cross-sectionally across lots of different kind of policy areas, because measuring the complexity of different policy areas would be complex, right? So one way you might think of testing it is like, well, we can test to see the extent to which agencies are pro-firm based on the level of complexity, because it's one of the predictions of the model. So you might include a cross-section of agencies, try to come up with some way of saying whether or not nuclear regulation or financial regulation or consumer products safety regulation is more complex, but those are going to be kind of difficult to do. Event studies, if one can come up with kind of key events that might increase the complexity of a market or regulatory arena, and then see whether or not there's an adjustment in the regulatory structure that's more pure, more pro-firm or more anti-firm, might be possible, but may not be very powerful if you're looking at kind of a single regulatory area. So what a grad student of mine and I are trying to do is to try to come up with ways of combining cross-sectional tests that have very similar policy regulatory arenas with the types of event studies in a way that might be more powerful. So we're collecting, and we're almost done collecting, data on state insurance regulation from the 1990s to the 2000s. And so we have lots of, we have one important event during this period, plus arguably trends in the level of complexity. So that event is the repeal of Glass-Steagall, which allows insurance companies to be bought up by banks and other financial holding companies, which we argue increases the complexity of insurance markets or regulating insurance markets at the states. And of course, over time, even absent Glass-Steagall, the types of investments that insurance companies make in terms of derivatives have gotten more complex over time. So we not only have the change in the market structure, but the change in the balance sheets of insurance firms that are going to be more difficult for state insurance regulators to regulate. So then we're going to look at the extent to which regulation within the states becomes more pro-firm or anti-firm over time as a function of whether or not the state governments themselves capture the principal's preferences, whether or not they're more pro-insurance or less insurance. Okay. So that's just to give you some sense of how we think the model will eventually be empirically useful. Just conclusions. Argument, policies, and complex domains are going to be biased toward the firm for two reasons. One is complexity makes it harder to regulate and revise what the firm has done. Second reason, it may be optimal to appoint a regulator that's pro-firm in order to mitigate that uncertainty somewhat. So since these pro-firm biases may be part of an optimal regulatory design and therefore consistent with democratic controlled agency, we also think that the work has some implications for how social scientists think about capture. The fact that many financial regulators used to work at Goldman Sachs may actually be a reasonable response to the type of regulatory situation that the Congress and the President faces. Anyway, so let me stop.